All right. Well, thank you, Lori, and welcome all to the CCTV pipe crawler inspection. My name is Gregor Murray. I'm an engineering technician with Snohomish County Department of Conservation and Natural Resources. And we also have another presentation which will follow mine by Don McQuilliams. Don is with the City of Bellevue Public Utilities, and he is the operations manager there. So without further ado, let's go ahead and get started. So I'm going to give an overview here of the pipe crawler, which is housed in the Drainage Systems Management Group of the Surface Water Department within Snohomish County Conservation and Natural Resources. So a little bit about this nifty tool. It's a mobile pipe camera inspection that we can inspect assets with. As you see that picture of me there operating it and a catch basin, be able to take this throughout the county, and it's a great tool. So let's go ahead and get started. So the pipe crawler. It's a smart tool for stormwater infrastructure management. The reason why we got this, well, few reasons. One, we were using a contractor, Qualis, and it was just getting a little bit too expensive, and much of our system is aging and in need of evaluation. So we've got miles and miles of underground piping that are often difficult to access and inspect. We've got emergency repairs that are far more costly than proactive maintenance, and improved assessments enhance safety, efficiency, and regulatory compliance. So down there in the bottom left-hand corner there, we have one of our inspectors getting ready to put that into a failed pipe, which we'll get to a little bit later on in the presentation. So just kind of as I just mentioned, we've got infrastructure problems. We've got cracked, corroded, collapsed pipes, blockages that can reduce flows. They're hard and costly to inspect, and higher risk of flooding, and sinkholes related to the stormwater infrastructure. So the solution to that is the pipe crawler. So this robotic tool is used for confined space enclosures entries, provides video and location data from inside pipes and different types of stormwater assets. It's safe, efficient, and very precise. So the key benefits for this, kind of just to reiterate what I said, inspections are completed faster with less disruption. The safety, it reduces the need for confined space entry. Compliance, it also supports NPDES and environmental regulatory. And then transparency, video evidence builds public trust. The cost savings prevents costly emergency repairs. So to the left there, that's another shot of the pipe crawler. Um, we have it operates in two different types of configurations. That's just a driveway culvert there we're getting ready to inspect. So as you could see there, we've got the pipe crawler. It connects to the reel there, and then the reel is connected to about a 9.5-foot, 10-foot cord that connects to the remote there, which gives us a perspective in real time of what we're looking at. This has a full-on automated video inspection report. We're able to take photos of the assets in real time, and the camera itself has a front-facing camera and a rear-facing camera as well. To touch bases a little more on the configurations of the pipe crawler, so we have the pan and tilt we just saw there. Most commonly used is the pan and tilt. There is a camera in the front of this and in the back. And then in the raised arm there you see to the right, we use that for vault inspections. This pipe crawler is fully submersible, so it's able to operate underwater. The only caveat to that is at times if the water is highly turbid, you won't get necessarily as clear of a video. So the raised arm is better in areas where we can raise that above the water and get a better visual perspective of what we're looking at. Works great in larger culverts with water at the invert settling, and as well as just mentioned in vaults too, stormwater vaults. So a few different uses for the pipe crawler, as just mentioned, and this is going to be going off of things that we've recently looked at. We've had this pipe crawler now for just about over a year as far as actively using it. We're getting up to speed on it a little bit more. So it's a newer program for us, not as extensive as Don's program. He has a more of a robust and more built program, which we'll get to a little bit later. But we'll get into a little bit of what we've been using it for, which is pipe inspection for conveyance, catch basins and assessments, locating missing assets, and just mentioned vault inspections. So here's a few of the here's a few projects we've actually used it out in the field. So in this situation here, as you can see, we had road maintenance crews come out and clean a pipe with the jetter to remove water and sediment. The clean pipe facilitates free movement of the crawler within the confined space and improves visibility of the infrastructure conditions. The data collected includes the videos and pictures of the precise location. We then enter that information into Cartograph, which is our asset management system. And then by that, we can facilitate a work order. We'll get pushed to road maintenance for the replacement of that pipe. And to the left there, you see the jetter head is going into the 12-inch concrete pipe. They're sucking at any type of blockages to get that clean freedom of movement for that pipe crawler you see there just behind the road maintenance worker. And then in this situation, we were able to just drop it right in. It's usually done by a group of two individuals. You have the operator, then you have someone else lowering that camera into that asset. And then you see they're leaning up against the fence, but we'll get to a little bit later. That's the saw and locator. That'll come in handy when we're trying to locate a pipe. Say it's 5, 6, 10 feet underground. We want to find a precise location of that. We can go ahead and mark that where that pipe, where that video camera is. So here's inside that pipe I was just talking about. The pipe crawler was sent up that 12-inch concrete pipe. The inspection confirmed that we had a collapsed pipe with root intrusion. This is one of our what we call off right-of-way drainage facilities. Um, so then, as just mentioned, the drainage inspector then will go out and attach a video and these photos to a work order in Cartograph, which will facilitate a work order for road maintenance to then go in and repair that asset. Here's another here's another scenario we used for a draining complaint. We were surface water management. We were getting a complaints for some pooling water on some cross culverts from a citizen. So the pipe crawler was sent in inside the pipe to assess the condition of the driveway culverts. So when we sent that in there, the findings showed us that we had two improperly connected two points, or without a catch basin, I should say. And you can see that there from those two pipes joined in at the seam there. There's rock intrusion. There's no proper sealing there at the bottom of the invert. The data then is collected, as just previously mentioned. And in this case, this project was sent over to our capital group, which is our drainage investigations group, for further analysis to process that. And to mention, all these projects are in the right of way. Lastly, here's another one for root intrusion. We were getting another complaint regarding some water that was backing up in the right of way. So maintenance crews put in their jetter head. We're only able to get past about 12 feet in from the basin to the pipe out. And so the camera was set up, and in this case, we saw root intrusion. However, the root saw that road maintenance set up was unable to cut through it due to the extensive diameter of the root intrusion on that stormwater pipe. So in this case, this would facilitate a replacement of that section. So kind of going back to what I said about the sonde locator. So here we have the surface water management team is locating a pipe separation with the sonde locator. The sonde is a great way to have an exact pinpoint precise location of that pipe crawler where it's at. And so previously just shown that those two pipes that were separated there improperly joined. Well, that location right there, if we see one of our inspectors holding the sonde, is where the pipe crawler is. So in this case, we will mark an X on that and facilitate a work order, excuse me, so road maintenance crews can come out and make that proper joint connection and put it in a catch basin. So what is the real world impact of this pipe crawler? Well, we have early detection of collapsed or blocked pipes, fast response to citizen complaints in regards to pooling water, etc., and prevention of flooding and property damage. It also provides clear documentation for maintenance and capital planning. Return on investments, faster inspections equal labor savings. Early detection is lower repair costs and reduce safety risks, fewer incidents and liability. We have proactive management, saved and avoided emergencies. Thank you. That concludes my presentation. I would be happy to answer questions after Don McQuilliams' presentation. But if you guys have any other questions um, after the presentation, like I said, we can ask, or feel free to jot down my email there if you want to send me any other questions. So thank you very much. And without further ado, I will stop sharing and hand it over to Don McQuilliams.
Thanks, Gregor. Nice presentation. So similar to Gregor, we started our video program. His is newer, but we started ours about 6 years ago formally. But prior to that, we were using contractors as well. So back then it was Bravo, and we spent a lot of money on video work through Bravo. And then it was really hard to keep track of the files that they sent us because they were just all image or digital files, and we couldn't really put them together in a nice database. So today I'm going to talk to you about our program, kind of the different aspects of what we do with it and how it's evolved over time. But first, let me introduce you to our equipment. So we're a Q's shop. So we have a CCTV van. It's got a K2 camera system in it. Has an evaluation station, kind of the brains of the camera. And then that also goes into our software, Granite Net, that helps us rate the pipes. We run two cameras. The Oz 3 camera is kind of the workhorse camera, and then we also have a duck camera, or it's a digital camera that takes hundreds of pictures every as it goes along. And the idea behind the duck camera is that you can just run it down the pipe, and you don't have to stop and do the ratings every single time, and you can rate it after the fact. And we run these on a compact pipe ranger transporter, and we have wheels and tracks, but most of the time we use the wheels. Then we also have a little 2020 push camera that we use occasionally when we're doing customer service calls. So I talk about three things. So our program goals, it's run by a full-time engineering tech that we have, a technical specialist for the program, and it supports our condition assessment program. So this is down out of our engineering department. So all of our video that we get feeds into her program, and she manages condition assessment for the entire utility, so stormwater, wastewater, and water. We also do system investigations to try to find out what's going on inside our pipe, and occasionally we get good little pictures of like this nice little salamander here. And then we assist our construction program when they're doing repairs out there, and I'll show you a portion of that as well. So our condition assessment program looks at the entire system. So we have over 400 miles of pipe. The goal of the internal program is to do 20 miles of pipe a year, and then it gets scored on a 1 to 5 criteria inside of granite.net, and that's a picture of what that software looks like over there. And that stores all of our videos over time and gives them all a rating, so we can upload all of that into the condition assessment program software that our manager runs, and then she can evaluate the entire pipe. And based on that, she looks at when does it become a replacement or a renewal of a pipe under the CIP? And she's gone out 100 years on that program there. And then we get critical pipe deficiencies occasionally. So the 1 is a very low deficiencies, 5 are very high, occasionally critical. So if we have a critical deficiency, we find that right away, and we're able to assign a work order to that, either to our internal staff or over to engineering if it has to be a bigger capital project. And then the less than critical ratings, those get prioritized, like I mentioned. And then also on this, we do cleaning ahead of all of our video work, or the vast majority of it. And for those NPDS folks out there, if you do pipe cleaning ahead of video work, you can take credit for that under the new SMED points. So system investigation. So anytime we have a flooding event that results in any structural flooding that causes any damages, we want to know what happened. So we'll use the camera to go in there and look at our pipes for that. If the crew finds blockages and we can't immediately figure out what's going on, often they'll call in the CCTV truck to help them figure that out. Finding buried structures, it's really good for that. We've found a ton of buried structures looking at video work. We do root saw, a program through our CCTV. So our technical specialist, he runs our root saw program. We have about 40 sites around Bellevue that we monitor annually, and we put on a repair list, but they take years to get repaired sometimes. So until we can get to them, we put them on this list, and he goes out and looks at them every year, and then root saws the ones that he needs to do. And then we also provide customer assistance. We call the connections to our system to the private structure's lot connections. So that's where we use the smaller camera, or if they have big pipes, we'll use our camera to see what's going on and give them advice. And I have a short video of a root saw here if it wants to work. Let's see. There we go. So you're seeing the pipe cutter coming up through. That root on the top left was what we started with. And after working it for a few minutes, the video camera's able to sit right there on it and watch it until the jetting crew, when they've accomplished their goal. So they know that they actually got that route, and then they can move on to the next one. So kind of cool. Whoops, stop. Okay. Our construction crew goes out and they do internal repairs of pipes by pulling a pipe patch up into it. It's that guy on the top left there. So it's about a 4 foot long pig with some wheels on both ends. And then they put a band around the outside of it, and once they get it into place, they blow it up, and it's fiberglass with epoxy on it, and it blows up and it sits in place for about 45 minutes to an hour till it cures, and then they can deflate it and pull it out. So when we do these pipe patches, we pull the pipe patch pig in with the camera and get it right where we want it, because we have footages up on the top of the video that tell us exactly where we need to be. And then we sit there and watch it throughout the process to make sure that everything cures okay. And then we can watch it deflate and we can pull it back out. So it's really handy to make sure that we get those pipe patches correct. And we try to do, upwards of about 50 of these a year, sometimes more. So that's 50 repairs where we don't have to dig down on a pipe, and we're just able to fix them from internal repair in a couple of hours, rather than spending a couple of days digging down and fixing a pipe. Then we also do a lot of internal investigations. That one on the bottom left that you're looking at, that's a 36-inch CMP to concrete failure. And that brown area up on the top is where the CMP pipe has actually collapsed. And this became an emergency project down in the Lakehurst Basin because it carries Lakehurst stream through it. And we were afraid that if we left this any longer with all the construction going on 405, we may lose this pipe entirely. So we had to put together an emergency project and get out there and got that fixed inside of a few months. And like I said, it's short. That's all the slides I have for you today. So I will stop sharing and open it up for questions for either my presentation or Gregor's. You get the
Thank
chat.
you, Don and Gregor. Please feel free to raise your hand and unmute yourself and ask Don and Gregor questions, or put your questions in the chat. And there's nothing in the chat as of yet, Don.
Yeah, I'm just pulling it up. Brandon?
Yeah, hey, great presentation from both of you. Just a question, something that's always on my mind in the asset management space here at Redmond. I'm the asset manager for the Public Works Department. How about two-way communication in updating like your asset inventory in the system of record, likely GIS? Like, talk to me about maybe some of either your wins or challenges with the interoperability of those inspection systems like GraniteNet, and then where those underlying asset data are living in GIS or some other enterprise asset management system.
Okay, I'll start. Gregory, you can weigh in.
Okay.
So we run multiple systems in Bellevue, and unfortunately, they don't talk to each other very well, to be honest. So we run GraniteNet, and then we run Maximo as our work order maintenance system. And then we also have a GIS database, and the GIS database pushes to Maximo, but it doesn't go the other which way. And unfortunately, everything that comes out of GraniteNet, it just goes into our asset manager's model, but it's not updating any pipe size material or anything like that in the GIS. So we have some connections we need to make to fix that over the next couple of years, and we're working on it, but it's very slow.
Yeah, we have a similar pain point. That's why I brought it up. I just looking for free chicken. I feel your pain.
Yeah, we're operating Cartograph, which is a great, it's an intuitive platform. We've really liked it. It's evolving about every 5 years. They're coming out with a new user experience. In November, they're going to launch a new interface of that. Um, it's great. It's pros and cons to some folks. Some people say, oh, I don't like, they don't want the change. So, you get used to using this product and you get really efficient at it and then they change it. But that seems to happen with everything, right? ArcMap now to ArcGlobe.
Mhm.
But yes, so it's how it works with us is we have a full inventory team, which goes out, and it's a group of 3, and they go out and inventory assets. And so all their job is to collect data with survey grade equipment. And so all that information is then sent over at the end of the week to our GIS team, and from our GIS team, then they push that to our GIS, which gets integrated with Cartograph. And so every week everything is getting updated, and all the assets from Cartograph and GIS are meshed together. And so it's great. It's worked out great for us. We're able to create work orders on individual assets. We're able to create work orders from drainage facilities, stormwater drainage facilities, and not just from an O&M standpoint as well, but other departments such as our source control group is using it too, for follow-ups, inspections. It's a great program. We've really been happy with it. And again, just utilizing GIS and Cartograph has been very beneficial for us. It
Appreciate
also
it.
allows, yeah, it also allows too, I kind of touched on this too. It also allows us to say, if I take this pipe crawler out onto a pipe, so someone can set a Teams meeting and say, okay, we're going to go inspect pipe 55555. Where's it at? Oh, it's up in Darrington. Okay, well, we know right where it's at. All you got to do in Cartograph is put in that asset number. It'll tell you right where it's at on a map. You can go right to that asset. Everyone meets there. We take the video inspection. That inspection report, that video, and those footages are then uploaded. There's an attachment section within Cartograph that you can upload that to, and it's great. It also has the ability for NPDES tracking dates for your drainage facilities, your stormwater, off right-of-way stuff that has the pipes and basins with the 6 months turnaround. You can set dates on that as well, and it really acts as a really intuitive tool. We've been really happy with it so far here at Snohomish County.
I see a couple questions in the chat there. So one person asked, did you say your engineering team rates the pipes? And I think that was at me. No, our engineering team does not rate the pipes. Our technical specialist, the operator of the video van, is the one that rates the pipes, and they're PACP certified to do that. And actually, John MacArthur's his name, and I believe he's on here. And if we want to call him out and ask him details, I'm sure he'd be happy to pipe up. The other question I see is, do you guys generally code your pipes while watching or after the video? For the most part, we code while watching the video. That's just the preference of the operator. But that duck camera does allow for us to code the pipes afterwards. So if we want to make long runs of pipe and get a lot of video in one day, we do have the option of running the duck camera and doing it back in the office.
Yeah, for us, we have an overall condition assessment, so that gets integrated. That's integrated within Cartograph. So whenever we're going to go out and perform an inspection on an asset or a drainage facility, each individual asset is going to have what they call an OCI, overall condition assessment or inspection. That's going to categorize based on your drop-down menus, based on what you see, what you visually are inspecting. We'll give it an overall condition assessment. Say for like a fish passage culvert, our inventory team will go out. They're able to inventory across culvert based on what they have. If it rates below a certain rating, it'll trigger that in Cartograph. And then we have engineers that can look at that, create a query within Cartograph and say, I want to look at all cross culverts that were, fish passageable that have failed. We're calculating plunge pools, bank full widths, all the metrics that go into making what is a fish passage, what for the ability for the fish to go through. And when those fail, those metrics, then that gets pushed through to our capital group. So yes, that's done in real time and spot on. I do the same thing too. When I do my inspections, I'm going out to each individual asset and performing that overall condition assessment. What are the largest roadblocks to implementation, especially in regard to cartograph and GIS? Well, I would say one, it's costly. It's a costly system. So if you can get, the management or your upper peers, it can be very costly to start. There is some glitches. There is a lot of there's updates going on with it. So it, it, there's times where it's slow. There's times where we'll have something will be down in GIS, but I think that really depends on your department. Coming from a larger bureaucracy, we've got a lot of IT support, and we've got individuals that are dedicated in GIS, so they're very prompt to put in a ticket and get that issue solved. I typically see it no longer than a day I've ever had any type of issue with cartograph and GIS interfacing. But it's issues like that I will see from time to time. How did we decide on equipment? Well, that was actually done a couple years ago, and I sat in on that. And one of the individuals in this meeting, Corey Olson, he was in there with me as well. He's with the city of Spokane Valley now, but we sat in on that, and that was something that we decided upon. One, costly. This program for the pipe crawler and a couple of upgrades. The base of the crawler was around $50K, and we did some upgrades on the controller, so it was just over $67,000 for that pipe crawler. Don's program's a lot more. He's running about just over $700,000 for his truck, and outfitted with Q's cameras, so you can see the cost there can definitely add up pretty quickly. Secondly, we are not doing right now. We don't have the capacity to go out and do full-on condition assessments of all lineal feet and all of our assets within the county. We just don't have the manpower. We don't have the time to do it. So right now we're just kind of going on it on a as needed basis. So when we have an issue, if road maintenance has an issue with the pipe, if an inspector will go out and say, hey, I haven't been able to find this catch basin. It's buried under someone's backyard. It's under pavers. It's under 5 feet of dirt. We will go out and try and locate that. We work hand in hand with road maintenance. So we will oftentimes we will go out and they'll jet a pipe, and then we'll send the pipe crawler in, and then we'll take that sonde locator to go out and try and locate that. And for what we were doing, the pipe trekker was just seemed to fit our needs a lot more. So yeah, it's been great for us. Even though I guess I'd say the headquarters for this are based out of Quebec, so we've had pretty good help as far as getting assistance and getting parts. We haven't had to run into too many issues with that. So anytime we've sent something over to Quebec, they've been very responsive to jump on a Teams call with a few of us, answer kind of any troubleshooting Q&A, and then sending parts back hasn't been a problem. So are there any subscriptions or costs? Not that I'm aware of right now. No, we do updates on it, but no, we don't have any type of subscriptions for any types of costs. This is kind of just a one-time purchase, and I think sometimes folks too can kind of get a little leery and scared of, oh, it's a one-time purchase. You got folks come in, they want to sell you this product, it's very expensive, then they sell it to you and they kind of cut you loose and never respond to you. But Pipe Trekker has been great. They've been very helpful. All the updates that I've done on the software have just been through the controller itself. The controller itself is actually that controller itself was $12,500. So it's, in a sense, it's like a mobile computer. It's very intuitive, but it operates just kind of like a tablet, and kind of similar how you would do updates on an iPad. It also has the ability there to do those updates too. So it works great for putting in thumb drives, USB-Cs. You can download data. So in a sense, it's like a mobile computer itself. So it's been very helpful for us. Do we jet prior to inspections? Yes, we do typically, yeah. And that's why I said we work a lot with road maintenance. So Public Works is separate from Conservation and Natural Department of Conservation and Natural Resources. In 2001, I believe, is when surface water branched off from Public Works and was put under Conservation and Natural Resources. So we work hand in hand, though, because the group that I'm in is Drainage Systems Management, and a lot of the conveyance and basins are in right of way. And so we work hand in hand with road maintenance, and oftentimes we will have them come out and jet stuff for us. And most our inspectors too are not confined space certified, so we don't go into any type of confined space. So say if we had like an inside drop or something like that, or an offset drop into a catch basin, we utilize road maintenance to initiate the confined space entry to go in there and put the camera in manually for us. And it's been a great we've had a great partnership with them. So looks like you got a question there, Don, from Matthew.
Yeah, I see a question about, are we using NASCO or as close to NASCO as possible as your standard? Yes, to a certain extent. NASCO was developed for the wastewater industry, and the stormwater industry is a little bit different. But it's the same rating mechanism. You're giving it the same codes while the pipe or while the crawler's going through there. It's up to the operator to determine exactly how to put those codes down as to his knowledge of the stormwater system and what's going to be important to the asset manager. So if that answers your question. So yes, it's NASCO with a twist. And then I'd like to back up a couple questions. Somebody asked about roadblocks to implementation of a program. Like Gregor said, our biggest roadblock on this was price. Our setup that we have now is about 750K to operate that, but we didn't start with that. We started with a hand-me-down van from our wastewater department and then built a business case out of that. And I would say if you're trying to build a business case to get a video program, a very good way to do it is to start getting some video out there of some of your critical pipe deficiencies and build the case around the what if. So what if that thing completely fails on you? What's the risk? What's it going to cost? I showed you that one 36-inch pipe that was collapsing earlier. We found that before it completely collapsed. They were driving equipment over the top of that pipe that was just these massive cranes to build the wall on 405. And had they kept doing that and we weren't aware of it, and that thing would have collapsed, we would have had just a mess on our hands, because that's a stream. And it would have flooded the whole neighborhood down below. And so we worked with DOT to get that site isolated off so we could get that work done. And that was $1 million+ project just to get the emergency work done. You know, if it had failed, we'd be looking at probably 3 or 4 million in claims on that one. Any other questions? Nope. In response to the video inspection, have either of you used trenchless pipelining? Yes, maybe you missed the slide, Corey, but we do internal pipe patches with the video. As part of the video program, they go out and assist our storm crew, and they pull in the pig and do it that way. As far as lining the entire pipe itself, we kick that up to our engineering department. It's too big for us to do as just a maintenance crew, and it's a little bit dangerous too. I think Kirkland was playing around with the idea of doing some full pipe lining, so you might want to reach out to them and see where they went with that. Well, thank you, everybody. Appreciate the time, and I appreciate you listening today.